diving into something new, and honestly, a little bit mind-bending. It's a mathematical idea from a paper by Shaukat Ahmadi, and it's all about a symbol called 0m. The whole point of it is to completely redefine how we think about, well, nothing. So yeah, let's get into it. Seriously, think about that for a second. Sometimes an absence isn't just a lack of something, is it? It's a presence. Like that heavy, ringing silence right after a huge noise, or the feeling of an empty chair at a family dinner. These things aren't just voids. They feel active, they're meaningful. But how in the world do you capture an idea like that with math? Well, up until now, our tools for dealing with nothing have been pretty simple. We've got the number 0, which just means there's no quantity of a thing, and then we have the empty set, which means there are no objects in a group. Both of these treat absence as just a lack, a void that's basically waiting to be filled. But that's not the whole story, is it? I mean, as the source material points out, some absences are actually structural. The empty space inside a donut is what makes it a donut, right? The shape of a missing puzzle piece tells you exactly what you need to look for. These are absences that are actually doing a job. They have a real presence. And this is where our story gets its hero. To give this powerful idea a real mathematical home, the author introduces a brand new symbol, 0m. It's designed for one specific purpose, to represent this very concept of an active, present absence. So, what is this thing? Well, according to its core rule, 0m is a totally unique mathematical object. It's not zero, it's not the empty set. Its entire job is to represent the presence of something that isn't there. It doesn't just mean nothing. It means nothingness itself is here as a concrete thing. Now, to really get our heads around 0m, we can't just define it. We've got to see how it acts, how it plays with other things. And just like any other number or symbol, it's got its own unique algebra, a set of rules that are, frankly, pretty weird compared to what we're used to. Let's start with rule number 1. If you add a present absence to another present absence, you don't get two of them. You just get the same present absence. Think of it this way. If you add a hole to a hole, you don't like two holes. The original hole just remains. In math, this property, where something plus itself is still itself, is called idempotence. The next rule also makes a kind of strange sense when you think about it. If you multiply 0m by 1, and you could think of 1 as meaning full presence, the absence isn't erased or changed at all. The presence of absence just stays what it is. It's a pretty stubborn concept. And this really shows you its self-referential nature. Multiplying a present absence by itself just gives you, you guessed it, the same present absence. The main takeaway here is that 0m is fundamentally stable. It describes a state that, even when combined with itself, doesn't change one bit. Okay, so 0m has some funky algebraic rules. That's cool, but where this thing gets really transformative is in the world of logic. This one little symbol has the power to completely break the binary world of true or false that we pretty much take for granted. Let's see how. In classical logic, any statement is either true or it's not true, period. A light is either on or it's not on. This is a fundamental rule called the law of the excluded middle. But just look at this table. If a statement's value is 0m, if it's just plain absent, then asking, is it true or not true, doesn't give you a clear true. It stays 0m. And that's the absolute game changer here. 0m introduces a third state of being into our logic. A question might not have a yes or a no answer, because the whole basis for the question might be absent. The entire foundation of binary logic suddenly gets this third pillar. Now, I know this might all seem incredibly abstract, like we're just playing some mathematical game. But the reason 0m is so powerful is that this idea of a present absence isn't just a theory. It turns out to be a shockingly accurate way to describe the very fabric of our physical world. So where does this idea actually pop up in reality? Well, we just saw its role in logic, but the paper highlights two more incredible places: the very structure of space-time and the deeply bizarre world of quantum mechanics. First up, space-time. In the field of math called topology, a hole, like the one in a coffee cup handle, isn't made of anything. It has no actual points inside it. It's a pure absence. But that very absence is what defines the object's shape and its function. That hole is 0m, right there in the real world.
Okay, now for the quantum realm. For a long, long time, we pictured the vacuum of space as just empty, a perfect void, zero particles, true, absolute nothingness.
But modern physics has shown us that's completely and totally wrong. The quantum vacuum is not empty. It is fizzing with potential, with these virtual particles just popping in and out of existence all the time. It has structure, it has energy. It is, in the most literal sense you can imagine, the presence of the absence of particles. It's a perfect physical manifestation of zero ohm.
And this brings us to the biggest questions of all. By giving a mathematical reality to this idea of a present absence, the 0m symbol doesn't just change our equations. It really forces us to go back and rethink some of the deepest philosophical concepts we have, like being and non-being. What's so fascinating is how this brand new mathematical idea really echoes some ancient wisdom. In philosophies like Buddhism, there's this concept of shunyata, or emptiness. But it's not a void, it's seen as the foundational potential from which everything else arises. It feels like, in a way, 0m is giving us a formal language to talk about this profound idea that emptiness isn't a lack, but a source.
And that leaves us with a final thought to chew on. For centuries, we treated absence like it was just a simple void, probably because we just didn't have the right language to describe it. But by creating a symbol for it, we've started to reveal its hidden structure and its power. So it really makes you wonder, what other fundamental parts of our reality are hiding in plain sight, just waiting for us to find the right way to see